At the end of the lesson, you should be able to calculate the pH values of a strong acid and strong base. For example, determine the pH of a 0.025 molar solutions of hydrobromic acid HBr. So first, write down the equations. HBr plus H2O, we get H3O plus Br minus. Since this is a strong acid, it will undergo complete dissociations in water. So in order to calculate the pH, remember the formula of pH is equal to negative log concentrations H+. So the concentrations H+ here can be obtained directly from the molarity of the acid. So we just need to substitute the molarity values and we can get the pH 1.602. Next is calculate the pH of 0.1 molar CaOH2 solutions. So this is a strong base. So first we write down the equations. CaOH2 plus H2O, we get Ca2 plus 2OH. Make sure that the equation is balanced. So in order to calculate the pH, since this is base, so it produces OH ion, so we need to calculate the pOH first. So the formula to calculate the pOH is equal to negative log concentrations OH ion. And it is the same thing for strong base. The concentrations of OH ion can be obtained directly from the molarity of the strong base. Since the molarity of base is 0.1, so the concentrations of OH ion is also 0.1. But since it produced 2 mole of OH ion, so the concentrations is 0.2 molar. So we substitute this value into the formula. We get the pOH equal to 0.7. So in order to calculate the pH, we use the formula pH plus pOH equal to 14. So we can get the pH 13.3. So, at the end of the lesson, you should be able to explain qualitatively salt hydrolysis using hydrolysis equations and classify the salt formed from the reactions between strong acid and strong base, strong acid and weak base, weak acid and strong base. What is salt? Salt is an ionic compound that is formed by the reactions of acid with a base. So this is the general equations of neutralizations at HX plus MOH to get MX plus H2O. So basically it's an acid plus base to get salt and water. So in salt there are cation and anion. Please remember that cation of the salt is from the base and anion of the salt is from the acid. Example of salt is NaCl, NH4Cl, zinc sulfate, sodium ethanoate, CH3COONH4. Salt can be classified as a neutral, acidic, or basic in aqueous solutions as they undergo a process called hydrolysis. Hydrolysis is a chemical reaction between the anion or cation that produced from a salt with water molecules. The pH of the solution depends on whether hydroxide ion or hydrogen ion is produced from the hydrolysis reaction. Salt hydrolysis. This reaction is the reaction of an anion or cation or both of a salt with water molecules. There are three types of salt hydrolysis. The first one is salt from strong acid and strong base. Next is salt from strong acid and weak base. And salt from weak acid and strong base. So this is the general equations of salt dissociations. Mx will produce M plus X minus. So M plus here is a cation. When it undergoes hydrolysis with water, it produces MOH plus H plus. And if anion undergo hydrolysis, it produces OH minus. There are three types of salt here: neutral salt, acidic salt, and basic salt. So for the neutral salt, for example, sodium chloride, so first we are going to look at the salt formations. For the sodium chloride, it formed from NaOH and HCl. NaOH here is a strong base, and HCl is a strong acid. Next, the salt formed from the neutralizations of base and acid will undergo dissociations. So NaCl will undergo dissociations to form Na plus and Cl minus. Na plus here is a weak conjugate acid, and Cl minus is a weak conjugate base. Okay. Na plus is a weak conjugate acid because it comes from strong base NaOH. Remember that the stronger the base, the weaker the conjugate acid. And Cl minus is a weak conjugate base because it comes from HCl, which is a strong acid. And remember, the stronger the acid, the weaker the conjugate base. Next is the process of hydrolysis. Since both ions are weak conjugate ions, they do not undergo hydrolysis process. So, pH of a solution depends on the auto-ionizations of water. So we know that in the auto-ionizations of water, H3O plus and OH minus are produced. So in order to calculate the pH of the solutions, we can use the Kw equal to concentrations H3O plus times concentrations OH minus. And we know that these concentrations are equal. That is 1 times 10 to the power of negative 7 molar. So in order to calculate the pH, remember that the formula of pH is pH equal to negative log H plus. So the concentrations of H plus here is 1 times 10 to the power of negative 7. So the pH is 7. Since the pH of the solution formed is 7, so therefore NaCl is a neutral salt.